Hello, Professor. My name is Sarah Sackett, and welcome to my final project database showcase. We're going to be starting with my entity relationship diagram and my relational database schema. So on the left here, you see my entity relationship diagram. We have the three entities as required for students, course, and section. I'd like to make a note that I chose to go with student class registration because I felt that would be the simplest and most effective way to demonstrate my skills. Both of these are a little bit rough to look at because I made them in Microsoft Paint. Please don't mind my terrible diagram drawing skills. Starting with the entity for student, we have the relationships student attends section and course offers section, which connects them. You'll also note that this one is a cardinality because each section can only come from one course, but each course can offer many sections. You'll also notice that if you ever open up the list of courses in the college website. For students' attributes, we have the primary key student ID, first name, last name, major, and the foreign key section ID. Section ID comes from the entity section, who has the primary key of section ID, along with the other attributes of semester and teacher, and the foreign key course ID. Course ID comes from the entity course, who consists of the attributes of credits, course name, and course ID, who is their primary key. In our relational database schema, you can see I have taken this information and built it into a table header style. You have the primary keys all displayed on this side, the foreign keys connected with a little bit poorly drawn arrows, and the rest of the attributes listed here. Please don't mind this empty box. I forgot to erase that, and I'm too lazy to do it now. Over here in MySQL Workbench, we have the tables and queries that I have created. As you can see, my first table is the course table. It consists of the course ID, the course name, and the credits. Our second table is the section table. It consists of the section ID, the semester, the teacher, the course ID. Our third table is the students table, which consists of student ID, first name, last name, and major. And we actually have a fourth table, who I will be explaining the reasons for later, who is the enrollment table, consists of the enrollment ID, which is essentially the unique identifier for the instance in which a student enrolled in a section, and takes on the foreign keys of student ID and section ID. The enrollment table was placed here as part of the normalization process because I realized upon having, as you can see over here, the section ID in the student table, it was now impossible for the same student to be registered in multiple sections because that would cause them to have multiple student IDs. And I don't know if you've ever been to a college before, wink wink, but students usually only have one student ID, so the enrollment table fixes that issue by connecting the student IDs with the sections under the enrollment ID, of which there will be one, and then there can be multiple student IDs with multiple sections that will link back to a single student. That was, for the most part, the only piece of normalization that I had to do here. Most of my tables were built with actually all of my tables were built with a single primary key in mind. None of the table entries consist of more than one piece of data inside of each thing. That was what the enrollment table was for, was to prevent multiple attributes from having to be placed in one box of the student table. Moving on from that, we have the first of our queries, which demonstrates a basic select statement. As you can see here, it selects all of the students from the students table whose last name is Jefferson and orders them by their first name descending. I didn't have to do this last part, I just wanted to flex a little. As you can see, we have two students here named Samantha Jefferson and James Jefferson. They are two of the example students that I have loaded in this table, the rest of whom I will be showing off later. We have my second required query, which consists of an aggregate function and a table join. This query takes the sum of the course credits, which are labeled total credits taught, and also the section teacher. From section, it joins the courses and the section table using course ID and groups the answers by section teacher. So essentially what this shows us is that the teacher Gregory is teaching a total of 6 credits according to the tables. These are the credits for the year at the moment because I don't have any semesters located outside of 2024. I have fall, winter, and summer. So you can see that Gregory is teaching 6 credits this class year, Jeffrey is teaching 6, Adina is teaching 8. I don't know if there are actual limits for how much a teacher can teach in real life, but in this particular table there are not. I also have an insert into statement, and before we roll into that, I'd like to show you the contents of the tables that we have here. This is our enrollment table. It consists of enrollment IDs, student IDs, and section IDs. There is only one repeat student in here because I was kind of lazy and just needed him for an example. The student ID with number 3 is enrolled in 2 courses, section 1 and section 2. We roll over to the students table. Sometimes I forget I have to click that button. You can see the student IDs, the list of students. Adam Harrison is the student who is enrolled in 2 sections. You can see their first names, their last names, and their majors. Over here in these... Excuse me one moment, I can't type right now. The section table. We have the section IDs, the semesters, the teacher teaching them, and the course ID, which links the section to the course which it is from. Lastly, we will pull up the courses table in order to showcase the last of the 3 required queries that I have. So as you can see here, I have 10 courses: algebra, biology, botany, computers, etc. Lots of 3s, a couple of 4s, and a 2 in the credit options. If we come over to here, I have an insert into statement. As you can see, I have just run it, who inserts a new course with a course ID of 11, the name quantum computing, and it is worth 4 credits. As you can see over here, the new class has been added. It's worth 4 credits because quantum computing is relatively new and actually quite hard. Over here is an update, which updates the quantum computing course to the course ID 12 and renames it Updated Quantum Computing. It's still worth the same number of credits, so I told it to keep that the same, and it knows which one it is by using the course ID, which is the unique identifier. As you can see when I run the select command again over here, it now reads Updated Quantum Computing and course ID 12, course ID 11, and the other one do not exist because it was not added, it was updated. And our last one deletes it from the courses so that my courses can look nice and tidy again. It deletes it using the course ID from the courses table. And if we run this again, you can see that that item is now gone. The furthest down table in these course IDs is civil engineering once again. That is it for the queries. Now moving on to challenges addressed. I know you can't see it in my taskbar, but I actually have Access open right now. Why do I have Microsoft Access open? Because early on, I made my tables in Access, because Access is a relational database management system, and I thought it would have what I needed in order to complete my work. Well, I can make the tables in this section. It absolutely does not have any sort of function as far as making queries. For entering in the query commands, because all of your queries are made like this, right? So I can't make a query that way. No, I do not want to save changes. But something good did come out of the fact that I built my tables in Access. Aside from the fact that I can't actually use this as my final project because it doesn't have the querying requirements, it did give me a much easier way to visualize the data and information for the tables without having to constantly run select statements. So I was able to build my queries over here and then look at this table here and determine if it was showing the information I needed. and what might have been going wrong. I was essentially able to use these copies of the tables to troubleshoot my MySQL workbench while I was learning how to use this, because I haven't used this until yesterday when I started this project. I had literally never used this before. So that was kind of a learning curve for me. I had to learn how to make tables and schemas, and I actually spent a lot of time populating the databases using the insert into command because I didn't know where the GUI was to populate the tables manually. I believe I can actually do that inside of this query now. If I wanted to add an extra S here or something, I could do that. No, wait, no, it's not in the query section. Somewhere around here there's a thing that I can use to do that, and I found it previously, but I don't know where it is now. We're gonna ignore that I did that, thank you. But yeah, so I had the access file, and I used it for figuring out what was going on with my queries so that I could fix them and make them work better. I actually spent the most time on this particular query here because I managed to get this to show the teachers and the credits for each of their individual classes, but I was trying to get the sum function to work, and it didn't want to, and I actually went out to try and code it to do this, and went all the way around in a complete loop to the point where when I finally got the code working again, it was displaying the same wrong information I had started with. Which is kind of funny, admittedly, but we did get here at some point. Now that we've finished with the challenges addressed, I would like to go over the potential future enhancements for the SQL database. The biggest idea I have here for potential future enhancements would be to add a table to keep track of teacher information. Currently, the only mentions of the existence of a teacher are in the section table, and well, that's technically the only place I need them right now. Teachers are people too, and just like students, they have names and... well, I can't think of the word right now, but it's like a major for teachers, except they're already graduated, and it's not degrees, but like maybe a teacher has a focus and they only teach math classes, or there's a teacher who only teaches programming, that kind of thing. But teachers, they have identifying information too. So a potential future improvement for this database would be to add a table that connects to this one and keeps track of things like staff IDs and which department, that's what it is, department they work in, and which sections they're teaching through table connections and such. That's one of the potential future enhancements that I came up with. I'm sure that there are other things I could do in terms of enrollments and students that might keep track of more information. For example, I could add sections about students' genders, and other important student information, because these are people and there's more to them than just their first and last names. Aside from that, that's pretty much everything I had to cover about my database. Thank you for listening to my database showcase presentation. I hope that I did well, and I hope that you have a nice holiday. Toodles!